All right, guys, here's 9.3.17. And again, this is well, it's a little different than the 9.21. So let's just go through it. Suppose the average size of a new house built in a certain county in 2006 was 2,279 square feet. A random sample of 25 new homes built in this county was selected in 2010. The average square foot was 2192 with a sample standard deviation of 220 square feet and an alpha of 0.1. So as always, I just start with what I know. So our expected mean, or the claimed mean, however we want to say that, is 2279. The N, or sample size, is 25. Our X bar, or sample mean, was 2192. And our sample standard deviation, which is usually denoted with an S, is 228 with an alpha of 0.1. So that's everything we know. So the first thing it wants us to do is figure out our hypothesis. So again, if the claim is that it's 2279, that would be our null hypothesis, that the expected mean equals 2279. And the alternative hypothesis would be that it does not equal 2279. So that should be our null and alternative hypotheses. All right, so now it wants us to determine our critical values. So in this case, instead of a critical z, we need to find a critical t. And the reason we know that is because we don't have a population standard deviation. Instead, we have a sample standard deviation, which we're going to have to use as an approximation for the population standard deviation. So anytime you don't have the population standard deviation, you're going to use the student's t distribution because it has a wider spread and allows for a little more error. So our critical t is going to equal t dot dis dot 2t. 2t means it's two-tailed. I don't know why there isn't this option. I'm sorry, I think I did that wrong. Sorry, t dot inv, inverse dot 2t. I don't know why there isn't this option for normal that it gives us the two-tailed, so we don't have to do all of the alpha divided by 2. But when you're doing the t, there's a 2t function for two-tailed. You could just do t dot inverse and then still do the alpha divided by 2, and it would get the same answer. Anyway, so we take our probability and we just put our alpha in there, and then our degrees of freedom is n minus 1. So there's our critical t. Because this is two-tailed, it's going to be plus or minus that. And it wants it to 3 decimals. You got to be, this problem got me earlier because I was not reading it carefully. So negative 1.711 and then positive 1.711. All right, now we're supposed to do our t-test statistic. So I left up here the formula that we used in the 9.2 problem. And you can see that this formula is exactly the same, except instead of the population standard deviation, we just put in the sample standard deviation. Everything else is the same. So this is our X bar. Whoops, I didn't do an equal sign. I do that a lot, or don't do that a lot, I guess. X bar minus the expected mean divided by S, which is our sample standard deviation, over the square root of n. So there's our t-test statistic. Wants it to 2 decimal places, so it's 1.91, negative 1.91. There we go. All right. So in this case, our test statistic is further away from the mean than the critical values, right? So it is less than negative 1.711. So what that means is we're going to reject the null hypothesis that the mean would equal 2279. So I'm going to say reject the null hypothesis. The data provides sufficient evidence to conclude the average house size has changed. Finally, it's going to want the p-value. Remember, the p-value is just the probability of getting a test statistic of negative 1.907 or plus or minus that equally. So there's a weird quirk in Excel, which you probably know. There's lots of weird quirks. But it doesn't like when we use this, we usually use our test statistic, but our test statistic here is a negative, and it likes that as a positive. So I just have to do equals t.dist.2t. And then for my x, I'm going to have to do a negative of that value. So in other words, it's going to make it a positive. You could also use absolute value if you wanted. Anyway, so it wants the positive value of that. Otherwise, it's going to return like an error. And then degrees of freedom is n minus 1. Oops, I think I didn't close that parenthesis out. And that's going to be our p-value. Again, I don't have to multiply it by 2 because I used the 2t formula. I was already telling Excel that it was two-tailed. So 0.068. And there we go. So hopefully, again, that was useful to you. And thanks very much.